Hello. The short video is on how to make the examples for the course on advanced programming for scientific computing up and running. The first thing you have to do is to go to the GitHub site. This is the GitHub site of the PAX examples as indicated in the lecture slides. And what you have to do, first of all, you have to copy the address of the repository. Since I've told you that it is much better to use SSH keys to store your SSH keys on the GitHub repo, I assuming you have done it. So you choose the SSH protocol and you copy the address. Then you can go to any directory, any folder in your Linux box where you want to store the PAX examples and do git clone recurse submodules, okay, and the address you have just taken. It takes a little time because the repository is a bit large, so you need some time. Also because you have a lot of submodules, so it's also taking the submodules. We have to wait a little bit. Sorry, take some time. You can, in the meantime, go and have a nice coffee, or a good finishing up. Some modules are just links to other Git repository governed by other people, owned by other people, that I am just using, okay, for the course. So these are not mine repository, a repository made by somebody else. Okay. Going PAX example, at this point you have a directory called PAX examples, and here what I suggest you is to read the README files here and in the examples directory, because in fact what I'm saying in this video is contained with even more details in the README files. Okay, but let's suppose that at the moment you are lazy and you don't want to read the README files. The first thing you have to do is to go to the extras and compile the extras. This is also a good check to see if everything is set up correctly in your Linux box. In particular, you must have a CMake installed because some of the extras use a CMake for compilation. And to simplify life, I have created a little script that does everything for you. So you just have to type dot install extras, okay? Dot install extras, carriage return, and then you have the extras installed. Also, this takes some time, but luckily you have to do it only once. Ignore the warnings. You have to do it only once. It takes some time because I've set up the compilation also to run some tests in some of these features, and so it takes a little bit time. You need also to have the boost installed. Okay. If you don't, if you're using the modules, you just have to do module load boost probably, right? To have the boost available. But this is something that you will see also during the laboratory session. It takes some time, unfortunately. You may run faster here, increase the speed of the video if you want, because it's going to take some time. And unfortunately here, I cannot suspend. Let's see if I can suspend the video. Uh, yes, I will pause until it finishes. Okay? Okay. It has taken quite a time, so don't be afraid. Leave it finish. If everything went right, you should have installed the project and all these installation instruction on the screen. Okay, you were gonna have quite a lot of warnings. Don't worry, it's fine. Okay, if you have your Linux box and your modules set up correctly, the compilation should end correctly, okay, with this type of messages on your screen. Now you have done this part, and now let's go to the real part related to the examples. In the examples folder, you have a file that is called makefile user, okay? The first thing you have to do is to copy this makefile user into makefile inc. Okay, and edit it with your preferred editor. I'm using here makefile.inc. Actually, before launching the editor, do this pwd that prints the directory you are in this moment. At the moment, I am in the directory with this full path, and I copy the path. Okay, copy it. If you want, I can do it like that. Copy, and then I edit makefile.inc. Gedit makefile.inc. It's all explained inside the file. In principle, if everything is set correctly and you're using the modules, in principle, what you have to do is just changing this line by putting the path you have copied before. Maybe you need also to indicate where you have stored the Eigen library, but if you have set these environmental variables, that is the one that has been set by the module automatically, the modules know where the Eigen are, and so this will be done by the modules, and also the rest for OpenMPI, maybe for parallel implementation, for if you're using the parallel version of the standard library utilities, you need to tell where to find the threading building block libraries. Normally, in a native Linux environment, they are here. Again, the modules should give the right path if you're using the module. The same thing for the boost and the rest. So in principle, you should have to change only this line, okay? And then you save everything, you close, and you are ready. You are ready to go into source and to test any of the examples. But what I suggest you is first to go into utilities, because utilities are, as the name says, utilities that are used by many other examples. So it is better to install them so that they become visible to every other example. To do that, you just do make to compile, and if everything is fine, they should compile with no warning, no error, and then you just do make install to install them. If you really want to be complete, you also go into linear algebra utilities, because this is another set of utilities that have been put in another place, and you do the same thing. Here you just need make install, because they're all header file. You just need to do make install. So now you have really completed the setup. Now practically all the other examples should work as a charm. If you want, for instance, have the examples on the aggregates, you can have a look at the README file to understand what is inside. There is also a little note, and there is a make file if you want to try the example to compile it, just run make. And if you want to run the example is in this case, you see it here. The compilation is always unclear, so you see what the compiler is doing. Is creating a executable called main, and this is the result. That's it. Enjoy the examples, try, and if you have problems, don't be afraid to ask. Please register to the forum on the Webeep and pose your question to the forum so that the answer may be useful also for your colleagues. Okay?